Hello everyone. In this video, I'm going to do another example on modeling with linear function. I'm going to do a problem from the homework. On this question, we're given that suppose that the world's current oil reserve is 2,170 billion barrels. If on average, the total reserve is decreasing by 19 billion barrels of oil each year, answer the following. Part A, give a linear equation for the total remaining oil reserve R in terms of T, where T represents the number of years in now. Be sure to use a correct variable and review before you submit. Okay, so in this question, we're given the rate at which the total reserve is decreasing. So it's decreasing by a rate of 19 billion barrels of oil per year. And T represents the number of years. So when you're given the rate of change of the oil reserve per year, this is actually the slope of the function. So if you think about this, you typically when you have, let me try to annotate on this. So typically you have the equation y equal to mx plus b, right? And m represent the slope or the rate of change of the linear function. Now here, instead of using, y equal to mx plus b, we're going to use different variable. R would be the total reserve, the total oil reserve. So that's going to be R is going to be equal to, I'm going to say M. I'm going to use the same notation here. M is the slope, which is the rate of change of the oil reserve per year. And then instead of X, we would have T, M times T, and then plus B. So think of, it's a very similar formula, but now we use different variable because, in the question, they use different variable. So in this case for us, because we know the oil reserve is decreasing by 19 billion barrels of oil each year, that's tell me the slope of this function R. So because it's decreasing, the slope is going to be negative. So we're going to have a decreasing function, right? The linear function is decreasing. So M is going to be equal to negative 19. And then what else do we have? So once we have the M, we can plug into the equation and then try to figure out what the B is going to be. But of course, if we want to figure out what the B is going to be, we have to have at least one point, one order pair that belong to this equation. So because here in this case, I guess because we suppose that the current oil reserve is 2,170 billion barrels. So we want to use that information. And then T represent the number of years since now. So what does that mean? That means that since now is when T equal to 0, when T equal to 0, because T represent the number of years in now. So if T equal to 0 represent now, right now, the oil reserve, which is represented by R is equal to 2,170. So this information here tells us that I have an order pair that will satisfy this equation. The order pair is going to be 0, 2,170. Okay, so we can use this piece of information. We're going to use the slope here, and we're going to use this order pair in order for us to write the equation that model the remaining oil reserve. Okay, and this one is going to be fairly simple because when T equal to 0, if you plug into the equation, so basically if I'm doing this, if I'm doing what is it? It's going to be, I'm going to plug in R, which is 2,170. is gonna be equal to M is negative 19 times T is 0 times 0 plus B. Okay, so doing this math will help me find the B. Well, negative 19 times 0 give me 0. So I get B is equal to 2,170. So my equation, the linear equation that models the total oil reserve is gonna be is gonna be equal to negative 19 times T, and then added with 2,107. And that is going to be my answer for part A of this question. Okay, let's check that answer because I want to make sure that I get a correct answer before I move on. There you go. Okay, so let's try to do part B of this. We have 10 years from now, the total oil reserve will be, well, how many billions of barrels? So 10 years from now mean when T equal to 10. So all I have to do is plug in T equal to 10 into this equation. And then that would help me calculate the total oil reserve 10 years from now. Okay, so let's try that calculation. So I would do R is going to be equal to 19 times 10 plus 2,170. So I do that calculation on my calculator. So I get 1,980. So I would put 1,000. So 10 years from now, the total oil reserve will be 1,980 billions of barrels. And then the last part of the question is, if no other oil is deposited into the reserve, the world's oil reserve will be completely depleted, which means when it's all of them will be used up approximately how many years from now? Well, to answer that question, when the world oil reserve will be completed, will be completely depleted, that means when R equal to 0. Okay, so what I would have to do is substitute R equal to 0 into my linear model that uh, I got from part A, and then figure out the T, because the T would give me how many years from now the works or reserve will be completely used up. Okay, so let's try that. So I'm going to clear all of this and I'm gonna redo this. So I would have plug in, so R would be equal to 0. So that I would plug in R equal to 0. So that means I have negative 19T plus 2,170 is equal to 0. Well, it's equal to 0 because the 0 here represents when the oil reserve is completely used up. Okay, and then I just need to solve this equation for T. So I would subtract the 2,170 to the right-hand side, and then divide both sides by negative 19. So I'm gonna get a decimal answer, I'm pretty sure, because this 19 doesn't go evenly into 2,170. So let me do that calculation. I get roughly 114.20. Let's see how many decimal places. They want 2 decimal places, so 21. Okay. So let's just check. So basically, roughly 114.21 year from now, the oil reserve will be completely used up. Now here, we're assuming that if we don't deposit any more oil into the reserve, which may not be true, because before it completely used up, typically we would deposit more oil into the reserve. Okay, so we could actually check our answer here. Let's see, 114.21. Yep, that's so good. And then the other answer that we got earlier, which was 1,980 billions of barrels. That was correct as well. Okay, so hopefully that help you understand, the concept of how we could use linear function to model certain situation, some basic simple situation where linear function could be really useful. I will see you guys in the next video. Bye now.